This video contains the solutions for problems numbers 1 through 6 on your Physics C Mechanics Practice Test number 2. First problem, we have a graph of velocity versus time, and we're supposed to find the position graph that matches with this. Well, there's a couple ways you could approach that. You could say, let's see, this is velocity, so we're going to get constant velocity, and then velocity decreases to 0, and then velocity is negative, it goes to constant negative velocity. So this is all like moving forward and then moving backward again. So actually that's enough to say the only graph here of position that is moving forward and then backward again, moving forward and then backward. This is stationary, then negative velocity, stationary. This is stationary and then negative velocity and stationary. These are all wrong for this. The other way is to approach it by looking at the slopes of these. This has positive slope, then goes to 0, and then has negative slope, and that matches up to this. This has 0 slope. This is not equal to 0 there, so that's wrong. This has 0 slope at the start. Wrong. This has 0 slope at the start. This one looks like it might have the right slope, but doesn't do the right rest of the stuff. So A is the correct answer there. It's like a calculus question, really. An object is dropped from rest from the top of a 400-meter cliff. If air resistance is negligible, what is the total distance the object travels during the first 6 seconds of its fall? Well, use a kinematics equation. Delta y is equal to, I'm using y because it's going up and down. You could use x, doesn't really matter. Vi is delta t plus 1/2 at squared. It's dropped, so its initial velocity is 0. So that just gives me how far does it fall. Delta y is equal to 1/2. We're using 10 for g times first 6 seconds. So that is, let's see, half. This is 36. Half of that is 18 times 10 is 180 meters. That's D. Number 3. A 2-kilogram ball collides with the floor at an angle theta and rebounds at the same angle and speed as shown above. Which of the following vectors represents the impulse exerted on the ball by the floor? Well, remember that impulse, which we call J, is equal to change in momentum. And since the change in momentum is mass times change in velocity, right? Because mass doesn't change, so it's really about the change in velocity. So it comes in with this velocity, comes out with this velocity. And if you do the change in, if you subtract those, remember how you subtract vectors? You flip the second one around. So final minus initial, so it would flip that one around and put them head to tail, would give us straight up. And it makes sense that the change in velocity is straight up because this is also equal to, remember, momentum, or sorry, that impulse is force times time. The only force that the force can exert is a normal force, right? It can exert a frictional force, but assuming this is like pretty instantaneous, it's going to bounce it straight back up. So the correct answer is E. 3 blocks of masses 3m, 2m, and m are connected to strings A, B, and C as shown above, and the blocks are pulled along by that force. Well, this is pretty common sense, I think. I mean, this force here, the tension in this string needs to pull along these two. The tension in this string only needs to drag along these two, and the tension in this string just needs to drag along this one. So we could do a free body diagram and analyze it in more detail, but I think a little common sense tells us that, of course, the tension has to be greatest in C. If you want more detail, we talk about that, but that seems very intuitive to me that it would be C. I didn't do any more analysis than that. You could try setting up normal forces and frictional forces and tensions and so on, and I think that you'll find that in fact this is the one that has to be the greatest force, or the greatest tension, that string. Numbers number 5 and 6 refer to this graph. Acceleration of the block at t2, well, let's see, at time 2 we know that the force is 4 newtons, and since force equals mass times acceleration, acceleration is equal to force over mass, so the force is 4 newtons and the mass is 3 kilograms, so the acceleration is 4/3. A little bit of Newton's second law there. How about the speed of the block? Well, how are we supposed to get that from this? There's more than one way to do it. You could find an equation for acceleration and then take the antiderivative of that. But I chose the approach that impulse is equal to change in momentum. And remember, impulse is force, average force times time, and when the force is not constant, that's, and change in momentum is mv final minus mv initial. So I think we can do this, right? We have a force-time curve, so the area under that is, see, that's a 2x4 triangle, right triangle, so that area is 4. The mass is 3. Final velocity is what we're looking for, and the initial velocity is 0. It's initially at rest, so final velocity is also 4/3 meters per second.